So members, where did we stop? Where did we stop? We started what? Refraction of light, not so? Members?
Yes, teacher.
We started looking at reflection of what?
Light.
Of light. So where did we stop exactly? So to give you a quick reminder, we defined refraction. Who can remind us? Who can remind us and give the definition? Who can define first refraction of light? Yes? Yes, members? Members? Who can define first refraction of light? Refraction, we have already discussed that. Okay, so those are the things we discussed the other time. But before we look at this, because the other time we had no power here, so there was some part of correction that we were supposed to do. We were supposed to do correction. So let me first remove this. And we do correction for this paper. We first go through it, okay? Let's wait a bit. Let me open this. Members? Hello?
Yes, teacher.
Are you able to see my screen well?
Yes.
Okay. So let's do correction for this paper very fast. Let's do the correction first, and then we in the next session, then we shall continue with refraction of light. Is that okay, members? Is that okay? Members, is that okay?
Yes.
Okay. So we finished number 1. Now let's go to number 2. Let's go to number 2. Correction. Question number 2. So question number 2 is saying that is basically was on mechanics, on machines. So the first question is saying what is meant by a velocity ratio of a machine? Who can remind us velocity ratio of a machine? Who can remind us, define first that? Yes? Who can define first that? Yes?
The velocity ratio is the distance moved by effort to distance moved by load.
Is the ratio, is the what? Just a moment, please. Just a moment. Yes, is the what?
Is the ratio of distance moved by effort to the distance moved by the load.
At the same interval. At the same what? At the same interval. Don't forget that. At the same what? Interval. Good. That one is okay. Members, have you put that one down? Put it down. Then what about a pitch of a screw? Yes? Who can define first that? Members, what about a pitch of a screw? Yes?
Let me try.
Yes, please.
Pitch of a screw is the distance between any two successive threads.
Can you be loud and clear, please? Can you be audible enough?
pitch of a screw is the distance
Mhm.
between any two is the distance between any two successive threads.
Successive?
Threads.
Yes, over what? Over a screw, okay? Okay? So a pitch of a screw is the distance between two successive what? Threads over what? Over what? Over a screw. Is that okay, members? Is that clear? Are we together, members? Yes. So what are we saying? If this is a screw, take for example, we have all seen a screw. Let's say this is our screw, something like this. This is the screw. This is the what? The screw. Like that. We know that as we know that it has a what? The distance between the threads we are talking about. These are the threads. These are the what? These are the threads. Okay. So the distance between any of them, like there from up to there, that's what we call a pitch. That is what we call a pitch. That's what we call a pitch. That's what we call a pitch. So then part B, they're saying a screw jack with a lever arm should be of part B. So members, before even we go to that, we know that what we call a lever arm is this one here, where you use for screwing, you rotate, okay? So this is the lever arm. The distance from here up to here is it? This is going to give us the radius, because when you're rotating, you form a circle. You're rotating, you form a circle. So which means the distance from here is the radius. Is the radius. So when you are rotating, here is where you apply the effort. Here is where the effort is. Then the load is here. The load is there. Okay? So, like we have already stated, we said velocity ratio of a screw is given as effort distance, is the effort distance to load what? Load distance moved at the same interval. But now for a screw, the effort distance is the circumference. The velocity ratio will be the circumference, the circumference divided by, what about the load? The load distance is going to be because whenever you move at this one interval, the pitch will also will get deeper, it will get into the surface with the one what? With one pitch. So which means divide by one pitch. So that's what we get that. But we know that circumference is equals to what? 2 pi r. 2 pi r. What is going to be the radius? The radius is going to be the distance from this point up to this. So that's why many of you missed that. So let's look at that question now. They're saying a screw jack with a lever arm of 40 centimeters. That lever arm is going to give us the radius. The lever arm is going to be the distance from here up to here. So this is what we call the lever arm. That is the lever arm. So the radius, the lever arm, is going to give us the what? The radius r, which is equals to 40 centimeters. And a pitch. So they have given us the pitch. So one pitch, P, was given to be 2.0 centimeters. Now they want us, is used to raise a load. Now they want us to find the velocity ratio of the screw jack. So like I've already stated, velocity ratio will be equals to the circumference, divided by distance of one pitch. So velocity ratio will be circumference, which is 2 pi r, divided by P. So you find that now when we substitute that, make sure that before you substitute, make sure that this one, because remember they are ratios. They are what? their ratios, which means they must be of the same units. They must be of the same, what members? The same what? The same units. So now you can see these are all in centimeters, which means you can go ahead and substitute. So we shall have VR equals to 2 times, you can use pi, which is 3.142, times the radius, which is 40, divide by the distance of one pitch, which is 2, So what do you get, members? Can someone calculate for us that and give us the answer? Members, can you calculate for me that? Let me first get my calculator. So what have you got, members? What have you got? What will be the pitch? What will be the velocity ratio? So we shall have 2 shift pi times 40 divided by 2.0. What do you get? 120. So our velocity ratio will be 125.66. Therefore, we can say velocity ratio is equals to 125.66. And our answer, say we have given is to 2 decimal places. That's there. And velocity ratio has no unit. Don't forget that. Velocity ratio has no unit. Are we together, members? Are we together?
Yes, teacher.
You have seen how you calculate the velocity ratio of a screw jack, eh?
Yes.
Yes, some of you forgot that. Then Roman 2, that's saying state 2 practical application of block and tackle. That one, there is no need for discussing that. That one you already know. Unless if you've forgotten, then go and check your book. State the principle of conservation of linear momentum. Who can help us and state for me that? Who can help us and state for us that, members? State the principle of conservation of linear momentum. I remember we discussed that one at length.
Oh.
Yes? Who can state it for us? Yes? Cynthia. Please, can someone state for us the principle of application of linear momentum? Yes? Maya. Maya, can you state the principle of conservation? Can you state the principle of conservation of linear momentum? Yes?
Trial.
Yes, please. Wilma. Yes?
The principle of conservation of linear momentum states that if two objects collide, then the total momentum before and after collision will be the same if there are no external forces acting on the colliding object.
You said the principle of conservation, okay, of linear momentum states that for a system of colliding bodies, bodies, comma, the total momentum of the body or of the bodies remains constant, provided no external force acts on the bodies. Act on the what? Act on the what?
The body.
On the
The
bodies.
body.
Yes. So we are saying in a nutshell, you can say, someone can say the principal conservation of linear momentum states that for a system of colliding bodies, the total momentum before collision is equal to the total momentum after collision, provided no external force acts on the bodies. That one is also correct. That one is also correct. Someone can state it like that.
Teacher,
Yes?
teacher.
Yes, please.
Now, what if we say that the principle of conservation of
Yes?
linear momentum states that if two objects, then the total momentum and after the collision force acting on the collision.
That's what I've just said. That's what I've just said, Bernard. I've just said that. Okay. I said you can give it like this, or you can give it like the way you have stated. Okay. Okay. So that means if you have two bodies, suppose, let me say, suppose you have two bodies, A and B, moving with initial velocities u1 and u2, collides and move with final velocity v1 and v2 respectively. Let me just give you general perspective for that. So if I have this is the body A with mass m1 moving with initial velocity u1. Then I have another body moving in the same direction. Let's assume they are moving in the same direction. So this is B, m2 moving with u2. So this is it before collision. Then this one. So this is B, m1, sorry, moving with v1. Then this is A, sorry. Then B, this is it.